Hey folks, today we're going to do the worksheet on neutralization reactions. Short worksheet, not much here. All right, so we're just going to get right to it. When an acid and a base neutralize each other, NaCl, how about NaOH? NaOH plus HCl, what do we get? Well, the hydrogen goes with the OH and the sodium goes with the chlorine. So we get HOH. We can write it as H2O. I prefer to write it as HOH because we're dealing with acid-base reactions, and in our case, sodium chloride, which is salt. Now remember, any ionic substance that we create this way is considered a salt. It is not table salt. It's not edible. Don't go there. All right, but we just call it a salt. All right, so we're going to write and balance the neutralization reactions for these reactions. Now that is clearly an acid, that is clearly a base, so the H and the OH go together, so that we have HBr plus KOH, potassium hydroxide, all right, hydrobromic acid, and we form the H and the OH go together, so we get water, HOH, plus we get potassium bromide, which is KBr. Now of course these things are aqueous, so they're still dissolved in water. We got a liquid over here, okay? And these are both aqueous dissolved in water. I'm not going to write aqueous and liquid every time, but that's what they're going to be, okay? All right, here we have the hydrogen and the oxygen, hydrogen and hydroxide getting together. So that's HOH, and we're going to get the lithium and the chlorine coming together, so it's lithium chloride. That is aqueous, so they're going to be dissolved in water, and we're going to have liquid for our HOH. Now here I'm going to have to write this out a little bit because you'll notice you have two OHs, which means you have to have two H's, so we have to put a 2 in front of that so that we can balance this reaction, because we're going to produce two waters, two HOHs, and we're going to produce barium fluoride. But barium has a +2 charge, fluorine only has a -1, so it's BaF2. And that's why you have to have two F's on the left, excuse me. All right, let's do this one. We have two hydrogens, you'll notice. We have to have two OHs, so we're going to have to put a 2 in front of here. So we're going to end up with two waters, two HOH, and we're going to end up with lithium sulfate. But lithium has a +1 charge, sulfate has a -2, so we crisscross them, so we get Li2SO4. How about here? Very similar. Here we have a triprotic acid, phosphoric acid, and so we have to have 3 HOHs, which means we've got to have 3 sodium hydroxides so that we can get sodium phosphate, NaPO4, but there have to be 3 sodiums, so it's Na3PO4. As you can tell, guys, it's extremely important that you can balance equations, and it's also important that you can go from names to compounds, as you see here. All right, so we have H2SO4 and we have aluminum hydroxide. That produces water plus aluminum sulfate, AlSO4. Now aluminum is +3, sulfate's -2, so it has to be Al2SO4 3. Well, if we have 3 sulfates on the right, we have to have 3 sulfates on the left. That gives us 6 hydrogens. That means we're going to have 6 waters. We have to have 2 aluminums, and we're now balanced. All right, so that's a 3 right there. You have 3 sulfuric acids, 2 aluminum hydroxides. Right? Here we have phosphoric acid and magnesium hydroxide. So we're going to have the same problem here, where we are going to put together water, HOH, and we're going to put together magnesium, which has a 2+ charge, and phosphate, which has a 3- charge, so we have to have 3, we have to have 2 of these. So since we have 3 magnesiums, we have to put a 3 here. That gives us 6 hydroxides, so we're going to have 6 waters, which means we need 2 of those, so we can have 6 hydrogens, and we have to have 2 phosphates. All right, now we get to some fun ones where we're dealing just simply with words. Well, phosphoric acid, that's hydrogen phosphate, if you will. So we have hydrogen and we have phosphate, which is PO4. And hydrogen has a +1 charge, phosphate's a -3, so it's H3PO4. And we have silver hydroxide, which is AgOH, silver hydroxide. And it's producing, well, obviously it's going to produce HOH, and it's going to produce silver phosphate. Well, silver has a +1 charge, phosphate's a -3, so I need 3 silvers. I need 3 silvers, 3 hydroxides. I need 3 waters to match my 3 H's, so I am now balanced. Nitric acid. You have to know that that is hydrogen nitrate. So nitrate is -1, hydrogen's +1, so they cancel. That's hydrogen nitrate or nitric acid. And then we have iron 3 hydroxide. Well, iron is Fe. Hydroxide is OH. Please make sure to put parentheses around the hydroxide before you put the 3 there. If you just put the 3 there without the O's, without the parentheses, you don't have 3 O's. All right, so we're going to come up with HOH. We have to have 3 of them because we have 3 hydroxide ions. And the other thing we're going to have on this side is iron, and we're going to have nitrate. Now, iron has a +3 charge, so that means I need 3 nitrates. So that means I need 3 hydrogens and 3 nitric acids, and I am now balanced. All right, sulfurous acid. Sulfurous is hydrogen sulfite. So that's HSO3, and SO3, like SO4 and like S, all have a -2 charge, so I need 2 hydrogens. It reacts with strontium, and strontium is in group 2, so it is a +2 charge. So that means I need 2 hydroxides. And when I crisscross these, when I react these, I get HOH, of course. And you'll notice I have 2 hydrogens and 2 OHs, so that's really easy. And then I have SO3. Strontium sulfide. Sulfite. All right, I think that's it. That is. Enjoy your day. Let us know if you have questions. We'll be happy to help you. See you in class. Bye-bye.